welcome back. Today we're going to complete operations with polynomials. So whenever we add and subtract, we can use the commutative property and the associative property. And remember, we're trying to combine like terms and rewrite the equation or expression in standard form. So here we have the expression, and we have two polynomials, and you can see the addition sign here. So what I want to do is find the like terms. So we have 6x cubed and 2x cubed. We're going to use the commutative property and move them together, and I'm using parentheses, which is the associative property. And then we have, I'm going to go by order here, we have x squared and negative x squared. So I'll put those two together. We have a 4x, which is going to be all alone because there's no other like terms. And then finally, I'm just going to circle the constants. We have negative 7 and plus 3. So when combining the like terms, we only have to look at the numbers in front. So we have 8x cubed, and this will be minus 7x squared plus 4x minus 4. All right, so whenever we're having a subtraction, we have to make sure we're careful with this minus sign. Essentially, it means that we're going to be distributing that negative 1. We're going to multiply everything by negative 1 in here. And then we'll combine like terms. So I'm going to rewrite the first parenthesis here. We have 2xy squared plus 6x squared. And then multiply all of these terms by negative 1. So you have negative 2x squared y squared minus 3xy squared plus 2x squared. Now let's look for the like terms. So we have 3x squared y squared. We have another x squared y squared. So I'm going to put those two together. And then we have 2xy squared minus 3xy squared. And then finally we have 6x squared and 2x squared. So let's combine these. So looking just at the coefficients, we're going to have just 1x squared y squared, and then minus xy squared. And then adding those two, we have 8x squared. Now notice we do have this in standard form. When we look at the first term, that's a degree of 4 because there's 2 x's and 2 y's. The next term has a degree of 3, 1 x and 2 y's, and the last one has 2 x's. Now let's multiply polynomials here. We have a binomial and a trinomial. To multiply, we're going to multiply everything by 2m. So 2m times 3m cubed would be 6 and m to the 4th. And then we have 2m times negative 4m. So that's going to be negative 8m squared. And then 2m times 2, which is plus 4m. And then now we're going to look at the 5. We're going to multiply everything by 5 here. So 5 times 3, m cubed would be 15 m cubed. And then 5 times negative 4, m is negative 20 m. And then lastly, 5 times 2 is plus 10. So from here, I want to make sure I combine like terms, and the only like terms I see are the 4m and the negative 20m. So we're going to have 6m to the 4th plus 15m cubed minus 8m squared, and then negative 16, because that's 4 minus 20, m plus 10. Now let's look at the next one. For this one, it's a little bit tricky because we have 3 binomials, but remember we can only multiply 2 at a time. So let's first focus on the first 2. And remember, we're going to use the same acronym that we always use with binomials, FOIL. So when you look at the first 2 terms, so it's m times n times m times n, so that'll be m squared n squared. The outer will have negative 2mn, the inner plus 1mn, and then the last is minus 2. So I'm going to put that in parentheses, and we don't want to forget about that third binomial here. But before we start multiplying things, I want to make sure we simplify what's in this first parenthesis. So we do have like terms here. So we have m squared n squared minus mn minus 2. And we're going to multiply that by mn plus 4. So just like we did with the first problem, we're going to multiply everything by mn. So we're going to have m cubed n cubed minus m squared n squared minus 2mn. Now let's look at the 4, and we're going to multiply everything here in this first parenthesis by 4. So we'll have plus 4mn squared, both of these are squared, minus 4mn minus 8. And the last step is to make sure we combine like terms. And so we don't have any like terms for the cube, so m cubed n cubed. We do have some squareds here. So when we put those together, we'll have plus 3m squared n squared. We have negative 2mn and negative 4mn. That's negative 6mn. And lastly, the constant minus 8. So just remember, when you multiply polynomials, you can only multiply 2 at a time. All right, let's look at this example, and it's really just to check for understanding. So whenever we're adding and subtracting polynomials, we consider the set closed, meaning we'll get one, it won't change. It's going to be still the same. So if we have a polynomial here and it keeps going here and we add it to a second polynomial, we're always going to combine like terms. So these terms will be the same, and then we'll have the next set and the next set. So in general, you could always say that the sum of the polynomials is always closed. The exponents do not change. And that happens also with the polynomials when we're subtracting. All right, now let's look at an application. So if we have, Carolina has a wind chime store, and she wants to figure out what's going to be the profit. Well, she first needs to figure out her cost, or the price, and the number of items she's going to sell. So here we're given the function for the price. So if she sells 2 wind chimes for $4, she would get $8 because 2 times 4 is 8. So if we don't know the number of items or wind chimes she's going to sell, we can say that's just X. So her revenue will be the number of items that she sells, X, times the price that she sets, which is 48 minus 2X. Well, we know that you're going to get money from all the sales, but there's going to be a cost of making the wind chimes. And so the cost is 12X plus 64. So whenever we want to find the profit, we always subtract the cost from the revenue. So if we're given the cost here, well, we could say the profit for Carolina's store will be the revenue minus the cost. And we know that the revenue is, I could rewrite this as 48X minus 2x squared, and then minus the cost, which is 12x plus 64. Now remember, when we're subtracting, we have to distribute. So we get 48x minus 2x squared. Distribute the negative, so we get minus 12x minus 64. And if we're going to write an equation in standard form, well, we can write the negative 2x first, 2x squared, and then combine the 48 and the 12, so that's plus 36x minus 64. So that equation would model the profit for Carolina's store. All right, now let's compare stores. So say we have Carolina's store right here, her wind chimes, and we're comparing Q's flower pots. Okay, and we are given the equation for his flower pots. Well, you can see the graph below for Carolina's wind chimes. And for each of them, we're going to find the y-intercept. Well, remember the y-intercept, I'm going to zoom in here a little bit, is down here. So whenever x equals 0, that means we didn't sell any wind chimes. It's going to have a y-intercept of negative 64. So Carolina's store, so P of 0 is negative 64. So that means that she's going to have a startup cost of $64. So if she doesn't sell any wind chimes, she'll lose $64. All right, let's look at Q's equation here, which is R of x. So remember, we said when x equals 0, we were able to find the y-intercept. So if we're given the equation here, we can make R of 0. And wherever we see x, we're going to put a 0. And you can see right away that 0 times anything is just 0. So what does this say about Q's store? It means that if he doesn't sell anything, he won't lose any money. He does not have any startup costs. So the question was that it was asking who would lose more money if neither person sold any items. So we know that Carolina had a startup cost, so Carolina would lose more money. If neither of them sold any items. Okay, well, the last question here is looking at end behavior, kind of going back to the last section. So remember when we had this parabola here, we know that as x approaches negative infinity here, y is approaching negative infinity. And then as x is approaching infinity here, y is approaching negative infinity. So what that means is like that there is going to be a maximum here, and there's going to be a point where we don't want to sell any more items. So there, if Carolina sells more items down here, she'll actually lose money. So knowing that the end behavior helps us decide how many items Carolina should sell. Now we want to see Q's flower pots. So what I'm going to do is actually rewrite the equation into standard form. You can see right away that there are going to be 3 x's. But first I'm just going to FOIL this. So we have 10x minus x squared minus 30 plus 3x. So we have 10x squared minus x cubed minus 30x plus 3x squared. And let me write this into standard form. So we have negative x cubed plus 13x squared. We have 2 like terms here, minus 30x for this will be for Q's flower pots. Now we know it's a cubic, so his, and I'll write this in a different color, is going to be decreasing. So as x approaches negative infinity, y is approaching positive infinity, and as x is approaching infinity, y is also approaching it's going to be negative infinity. So comparing them, they actually have the same right-hand behavior. And knowing what a cubic looks like, we know that the cubic will probably look like this. So each of these points or each of these stores will have a relative maximum or maximum. So Carolina's store will have a maximum and Keogh's store will have a relative maximum. So Carolina and Keogh have a specific number I would say of items to sell for maximum profit. Now, reviewing what we covered for polynomials. Well, we actually, in this beginning, remember we're adding and subtracting using the associative and commutative properties for addition and using also the distributive property for subtraction. Whenever we want to subtract, we need to make sure that we distribute that factor. And then whenever we have the terms after we group them, we want to make sure we write them into standard form. Well, I hope this lesson was helpful, and I'll see you all in class.